Hello everyone, my name is Ankur and welcome to RJPT Simlab simulation. In this video, we will study about the Biostatistical Method in Experimental Pharmacology ANOVA Analysis of Variance. At the end of this video, we will be able to tell about what is ANOVA and what is the significance of ANOVA in experimental pharmacology. So now, let us start with the video. At first, let us see the introduction part. The introduction says, biostatistical methods in experimental pharmacology involve the application of statistical tools to design experiments, analyze data, and draw valid conclusions about drug effects. These methods help ensure reliability, minimize bias, and determine significance in drug testing. The above introduction paragraph says that this is a biostatistical method of experimental pharmacology, and the use of this is for the design of experiments, for the analysis of data, and we can draw a valid conclusion about the effects of the drug about the experiment. And these methods help us to ensure the reliability, minimize biasness. Biasness is the supportive of any one decision without any valid proof. So our decision will be unbiased and we can determine the significance in drug testing. For analysis of data, we use t-test, ANOVA, analysis of variance, and regression. These are the various biostatistical methods that we used in experimental pharmacology. Now, let us see what is ANOVA. ANOVA is a statistical method used to compare means of three or more groups to determine if there are significant differences between them. It basically observes difference obtained are either by chance or it's real. The above para says that this method is used for the comparison between three or more groups. When we have a group of subject which is more than three, then we use ANOVA for the determination of the significant differences between all the groups. And the observation of ANOVA about these groups are obtained by either by chance or either it's real. The purpose of ANOVA is that in experimental pharmacology, ANOVA helps analyze data from drug trials and experiments to assess the effect of different treatments or dosage. ANOVA separates the total variability observed in the data into components attributable to different sources, example treatment effect and random error. The above para says that this helps in the analysis of the data of the drug trials and experiments that we will perform in experimental pharmacology, and which we can assess the effect of different treatments about the experiment. And ANOVA help us to total variability. It separates the varies, which means that when we have more than two or three groups, ANOVA separates the differences between each group and we can compare it and we can see the differences between each group. And this helps, such as we can say that treatment effect and random error, these are the two groups about any experiment. So let us move on to the next heading. Why use ANOVA over multiple t-tests? Now, let me tell you about t-test. T-test is another biostatistical method and which is also used in experimental pharmacology. And in t-test, we compare two groups in the experiment. And in ANOVA, we compare more than three groups. Or we can say that we compare multiple groups. ANOVA controls the type 1 error rate that increases when multiple t-tests are used for comparison among several groups. This statement says that it controls the type 1 error rate that increases, which means type 1 error rate increases when multiple t-tests are used. Multiple t-tests, we compare between more than two groups for comparison among several groups. Now, let us see the types of ANOVA. There are two types of ANOVA. We have one-way ANOVA and we have two-way ANOVA. Now, let us see the assumptions. Each sample taken are normally distributed. The sample that we take for ANOVA are normally distributed into groups, and sample drawn are independent and random of another sample. When we divide groups, we draw sample and they are not biased. They are independent and we randomly select the samples and divide them into groups. And variance of data in different groups should be same. The variability of the data of the different groups should be same. The formula of ANOVA is variance between divided by variance within, which means the variance between the groups, which means between the different groups divided by the variance within the group. We have a number of data within a single group also, so variance within the group. The key terms that we use in ANOVA are F ratio, the ratio of variance between groups to variance within the groups, which means the F ratio is the ratio between the variance between groups, means variance between the groups divided by to variance within the groups, the F ratio, and the P value. P value indicates the probability that observed differences occurred by any chances, which means P value indicates the probability, which means the outcome, the probability of outcome or chances of outcome that are difference, observed difference occurred by chance, not by real, it occurred by chance. Now let us see the interpretation of ANOVA. That the test output includes an F statistic and P value, a high F statistic value and a low P value. P value smaller than 0.05 lead to rejection of null hypothesis. The above statement says that the test output when we perform an experiment and the output of the experiment includes F statistic and P value. There will be two values, F statistic and P value. And so if a F statistic value is high and the P value is lower than the 0.05, it will lead to rejection of null hypothesis. What is null hypothesis? The means of all groups are same, which means we are using a number of groups, we are comparing a number of groups and the mean of all the groups are same. It will reject the null hypothesis, which means all the mean of all groups will not be same. And alternative hypothesis, we have another hypothesis. This means the means are different for at least one pair of the group, which means when we have a number of groups, as we can say we have three groups, so the mean are different at least of one pair, which means we have a mean of one group is different and the two groups we have same. So mean of one group is different. This is alternative hypothesis. Now let us learn about ANOVA with the help of an example. This way we can easily understand how does ANOVA works. So the example says we have to perform an experiment, and the experiment says to compare the analgesic effect of three different drugs A, B, and C by measuring tail flick latency in rats. As we have already studied about the tail flick latency experiment, tail flick latency method is a pharmacological experimental method by which we study about the analgesic effect in rats. So about the experiment, how should we perform the experiment? At first, we need subjects. We need 15 rats and we will divide 5 rats per group, which means when we divide 5 rats per group and we total number is 15, then we can easily divide 3 groups. 5 rats per each group, group 1, group 2 and group 3. And we will assign drugs to each group. So group 1 has been allotted drug A, group 2 has been allotted drug B, and group 3 has been allotted drug C. We are using 3 different analgesic drugs, A, B, and C, and we will measure the outcome. How we will measure the outcome? By tail flick latency in seconds, pain response time after heat stimulus, which means we'll perform the tail flick method and the tail flick latency, which means the late flicking of the tail, it will be measured in seconds, and it will happen when the pain response and the heat stimulus, which means when the tail will feel the heat, it will respond to the heat stimulus and it will respond with pain at a certain time. So now let us see the observation table of the experiment. We have the column says rats number. We are using 5 rats for each different group. We have 3 groups which we have allotted 3 different drugs, drug A, drug B, and drug C, which denotes the 3 different groups, group 1, group 2, and group 3. So now we have this experimented data. So the rat 1 has taken the tail flicking for drug A at 4.2 seconds. Similarly, the rat 2 has taken 3.9 seconds for drug A, rat 3 has taken 4.1, 4 has taken 4, and then 5th rat has taken 4.3 seconds. And the mean of all the rats' time is 4.1 seconds. Similarly, for the second group, the first rat has shown 6.3, 6.7, 6.5, 6.8, 6, and 6.4. All the 5 rats have shown their time seconds for their tail flicking, and the mean is 6.54. And similarly, for the third group, it has taken 7.1, 6.9, 7.3, 7.0, and 6.8 seconds. And the mean of all the time is 7.02 seconds. So now we have calculated the mean of all the 3 groups. Now, let us see the calculation part of ANOVA. How do we calculate ANOVA? Step 1 says calculate the group means. That we have already calculated. The mean of the group A is 4.1 second, the mean of group B is 6.54, and the mean of group 3 is 7.02. So now let's move on to the second step. The second step says calculate grand mean. Then the formula of grand mean is total of all values divided by the 15. 15 is the number of all rats. So the total of all values, which means all the values of the all groups, which means the 4.2, 3.9, 4.1, and such that all the values we have to add it. So as we have written here, 4.2 plus 3.9 plus 4.1, we have added all the values, which is divided by the total number of the rats, which is 15. So after calculating, we have got 6.49 as the grand mean. So now we will jump on to the third step. The third step is about the sum of squares between the groups, which means we have to we have to sum we have to sum of the squares between the groups, which means we have three different groups. So we are performing this between the all the groups, all the three groups. So the sum of square between the groups formula says SSB is equal to n summation of square of bar xi minus gm, which is grand mean. So where n denotes the number of rats per group. We have number of rats per group as 5, and the bar xi denotes is the group mean. What we have found over here, the group mean, each group's mean. So now when we put the values into the formula, SSB is equals to number of rats we have 5, and the mean of the group. The mean of the first group is 4.1 minus the grand mean, which is 6.49, and its whole square. Similarly, for the mean of the second group, 6.54 that we have got over here, and then the grand mean and the whole square of it. And similarly, the third group's mean and minus grand mean and its whole square. So after calculating it, we have got the value 13.1645. This is the sum of square between the group, the SSB value. Now, at the fourth step, we will calculate the sum of squares within the group, SSW value. It is the sum of squares within the individual group. As we have individual groups, group A, group B, group C. So the formula of SSW says SSW is equal to summation of square of xij minus bar xi. So now we will put the values into the formula, as xij is the summation of xij, 4.2 minus 4.1 whole square. So xij is xij, which means initial value, and the mean value, j value, which is 4. Here, as we can see, 4.2 minus 4.1 whole square. Bar xi. The bar xi value is 4.1 mean of the each group minus the initial value. So 3.9 as the second value, 3.9 of the second rat of the group A minus the mean of the group and its whole square. So after putting all the values of the 5 rats, first rat, second rat, third rat, fourth rat, and fifth rat, when we put the value, we have got the answer 0.10. Similarly, we will perform this for the group 2, the drug B group. Similarly, we will put the initial value 6.3. We have got the first value as 6.3 over here, and we will minus it with the mean of the group 6.54. See, we are minusing it 6.54 and whole square. Similarly, we'll put all the values over here and we have got the answer 0.172. And similarly, we'll perform for the third group. We will minus the initial value minus of the mean of the group and its whole square. So we have got the value for the third group as 0.148. So SSW says is equals to 0.10 plus 0.172 plus 0. Summation. The summation of all the groups value is and has come the value 0.42. So now we have got our SSW value. We have calculated our both SSB value and SSW value. Now we will jump on to the fifth step, which is the degree of freedom, DF. It is also denoted as DF. So degree of freedom has two categories, and it is calculated between the groups and it is calculated within the groups. When we calculate between the groups, the formula says k minus 1, which is k is the third value, and which is minus 1. So 3 minus 1 is equals to 2. And within the groups, when we calculate it, n minus k. So formula says 15 minus 3 equals to 12. So now we'll move on to our next sixth step, which is the mean square, ms value. And when we will calculate the mean square value, we have again two types: the mean square value between the group and mean square value within the group. So the formula for mean square value between the group says SSB divided by degree of freedom of within the group. So when we put the values into the formula, SSB value, what we have got, the SSB value is 30.1645. So when we put 30.1645 divided by the DF of between the groups, degree of freedom of between the groups, it is 2 divided by 2. So we have got the value 15.082. And when we calculate the mean square values of the within the group, the formula says SSW divided by degree of freedom of within the group. So when we put the values into the formula 0.42 divided by 12, we have got the value 0.035. And now we will we will move on to a seventh step, which is the F ratio. As we know about the F ratio, we have studied earlier. F ratio is the ratio of variance between the groups to variance within the groups. It is the ratio of variance, which means differences between the groups to the within the groups. So when we put the value, the formula says that MSB divided by MSW. MSB divided by MSW. MSB is the mean square value of between the groups, and MSW is mean square value within the groups. When we put the values, we have got the value 430.91. It is the F ratio. And now let's move on to our last calculation part, the eighth step, where we compare the F ratio to critical F value. So at alpha is equals to 0.05, the degree of freedom 2 and 12, the critical value F value is 3.89. So since we have got our F ratio over here by calculation 430.91, which is very much greater than the 3.89, the result is highly significant, which means the difference between all the three groups is very highly significant, which shows the difference in the variance and the difference in the values between each group. So now let us see the conclusion of the experiment. The conclusion part says the ANOVA test confirms that the three drugs do not have equal analgesic effect, and this statistical evidence supports further investigation into drug C as a potentially more effective analgesic. The above conclusion part says that this test that we have studied in the example, we have seen in the example part, confirms that all the three drugs A, B, C do not have equal analgesic effect. It has shown different analgesic effects, and this evidence supports further investigation into the drug C, which is shown potentially more effective analgesic than the other A and B drugs. So now this is how we understand, we have learned how ANOVA works. It shows the difference between the effect of different groups that we used in an experiment about the study of the effect of drug. So now we have studied about ANOVA. I hope that you have learned a lot about ANOVA and how ANOVA is used, what is ANOVA, and how it is used in experimental pharmacology. So at this part, we can see the introduction part and all the written details on how to perform the experiment. We can learn it over here before going into the presentation part, so that we have an idea of about what is in the slides. This is a free material which is for the students who do not have any subscription to our RJPT Simlab. This data is valid for them. And when we see here download user manual, when we click it, here we have a theory file of the experiment. The aim is written over here, the introduction part, ANOVA purpose, why we use, formula, the example. Here we can see this is free for all the students, those who do not have the subscription of our RJPT Simlab. So now this is how we perform our experiment, and now we have completed our experiment. I hope that you have learned a lot about in this experiment and how ANOVA is performed and what is ANOVA and how it is used in experimental pharmacology. Thank you guys for watching this video, and for more such learning content, subscribe to our YouTube channel and follow us on our LinkedIn profile, on Instagram, as well as in Facebook. We uploads and updates our videos about like this learning content over these platforms. Thank you.